So thank you everyone for joining today. My name is Nathan Bacchini. I am a marketing manager at Data Science Dojo. And today I have Amar Jawad. He is a data scientist at Valsala out of Finland. And you're going to be talking to us about boosting LLM performance with Retrieval Augmented Generation, also known as RAG. So Amar, why don't you go ahead and kick it off? You will only hear from me if I need to interrupt you for any reason. All right.
Yeah, thanks. And let me just share my screen and let me know if you can see it. Just a second. Okay, so can you see my screen and can you hear me just fine?
Yep.
All right, great. All right, so boosting LLM applications with Retrieval Augmented Generation. Before we go into what we are going to do, let me just give you a brief intro of who I am, what's my education, where I work. So my name is Omar. I'm a data scientist. I've been working with Vaisala, which is a weather and industrial, measurement company. It's based out of Finland, but it's multinational. Like half our operations are in US. I did my master's in statistical data analytics from Finland a couple of years ago. Like I graduated last year, and then I've been working as a data scientist with Vaisala ever since then. Most of my work before generative AI came into scope was about anomaly detection, time series analysis, sensor data, IoT of devices. Now I've been since this year, ever since OpenAI released ChatGPT, I've been working with generative AI. I've been exploring the landscape. I've been working in putting some applications into production, um, playing around with a lot of Gen AI use cases, things like that. So if you guys want to know anything further about generative AI, feel free to reach out to me on LinkedIn. So yeah, I think enough about me. Let me just give you a brief idea of what our agenda is going to be. Excuse me. Today I'm just going to give you a brief. I'm going to tell you what retrieval augmented generation is, how it improves LLM applications. Then I'm going to show you a demo in Jupyter Notebook. It's a very basic demo, but it should be enough for anyone to get started with to sort of like get the ball rolling. And I'm pretty sure I've deliberately kept it simple because I want you guys to get the basics right, and then you can experiment on your own. Nothing too fancy, but still everything is covered. All the basics are in the place. So yeah, let me just give you a brief overview of what LLMs are. Those who have been interested in generative AI but haven't got the time to understand how LLMs work, let me just do a brief recap. So how do we make an LLM? Yeah, so that's where we should be starting from. So basically, we have this huge text data, like the internet, web pages, books, articles, Wikipedia, things like that. And what scientists do is they collect all of that into a huge data set, like terabytes of data. They put that in a blank LLM. So blank LLM is just a simple, not a simple, but a neural network, and it's blank. So basically, they train that on that huge data set. And what they do get out of it is called a pre-trained or a foundational model. And this foundational model, you can imagine it like a baby. So it has all the knowledge, but it does not know how to behave, how to perform, or what I would say, what is the ideal output someone is looking for. So this pre-trained LLM is further fine-tuned. And by fine-tuning, you're basically teaching an LLM to perform or behave a certain way. So for example, the chat version that you see, the chat GPT, so that is basically fine-tuned or trained on a data set that is in a chat format. So in a like a user and then a server. So these are like two people chatting, and then that chat is used as a training set for that model or that fine-tuned version of the LLM. Similarly, you have an instruct model where you give an instruction and the model follows that and gives you some sort of output based on that. And then there are models for code generation. ChatGPT can also create code. Then you have GitHub Copilot, which is specifically for code generation. So this is about how an LLM comes into being. But then there are certain drawbacks when you get an answer from an LLM. When you tell it something and then it outputs an answer, there are issue of hallucinations. Basically, LLMs are super good at generating random stuff out of thin air. So they might sound really convincing, but the answer would not be factual at all. And then the issue is that LLMs can sound pretty convincing, but they have no sources. They might not give you any source at all where that information is coming from. You can doubt the factuality because if an LLM is telling you something, make sure to check the factuality for someplace else as well. And then the LLMs are, since they are trained on public data, most of the LLMs, what they don't have is the private data or proprietary data of most of the companies. So for example, if you want an LLM that can give you answers or describe your own company product, chances are it won't know what that product is or what that thing is going to be. And one other thing is that LLMs are like frozen in time. They only know the information that is in their initial data set. So for example, in case of ChatGPT, it's trained up till the information is up till 2021. So any information or something that happened in 2022 or 2023, that would not be in the memory of the LLM, or LLM would have no information. Even if it says something, but it would be entirely made up. It won't be factual at all. So retrieval augmented generation, this RAG word has been thrown around a lot. It's a method or a architecture that's been developed to address the issues regarding hallucination, factuality. We want something and to update the knowledge of the LLM. So basically, we use the comprehension power of the LLM, but we provide external knowledge to the LLM so that it can reference and sort of answer based on that information as well. So usually what happens, for example, you have a query, you have a question, and you have an LLM. And when you send that query to the LLM, you get an output. But that output might not be factual at all. And let's just stop it right there. Yeah. Yeah, maybe I can take a question right now and then we can talk about RAG. So one question is, or a comment from Kumar is, some LLMs like Bing Chat are giving sources of output. And yeah, the reason they are giving sources of output is that they are using RAG in the background. So they're also using retrieval augmented generation to give you these sources. So it's not just the LLM giving the sources itself, but also it's the sources are coming from the RAG architecture. And then we also have this another question from Jeff. So the question is, I saw some people talking about RAG as an alternative when companies have some security policies where they can't share private information with the LLM. But once the data is recovered using RAG technique and sent to LLM as an additional context, this statement is not true, right? Just a second, let me understand what you mean. But once the data is recovered using RAG technique. So yeah, so basically what I understand is, yeah, so we basically send the company data as a additional context to the LLM. And without sending that data, the LLM won't know what to answer or what the factual answer is. So basically what it does is you give it the context and it looks into the context and retrieves the most relevant information based on the question that you have. And I hope I answered your question appropriately, because that is what I understood from your. And then we have, yeah, any other questions? All right, Shumail Yerushalmi, I'm sorry I butchered your name, but that's how. Question for Q and discussion: how integration between LLM and RAG can support development quality AI and digital technologies? It's a long answer, and I think I should do that once I explain a bit more about RAG, and meanwhile we can put away the rest of the questions away until then. Uh, so yeah, so let's just go back to RAG, Retrieval Augmented Generation. So in general, if you have a query, you send it to an LLM, you kind of get an answer, but no source with that. So where does RAG come into play? So basically, RAG is the architecture where you provide some sort of factual context to the LLM. And that factual context comes from your knowledge base. And what your knowledge base is like your collection of your PDF documents, your PowerPoint presentations, your Word docs, or your text files, basically anything with text data. So you can just load up all of that in a knowledge base, and you build the architecture or the LLM application architecture in a way where you are pulling that all of that information from the knowledge base, or you are pulling the most relevant information from the knowledge base based on the query that you have. And once you have that, the query and the context, the LLM analyzes the context and gives you an answer based on that context only. And since we know where the context is coming from, we are able to attach some sort of source to it. So the source knowledge or the link or the hyperlink or the like the connection to the where this information is coming from is it comes as a metadata in the context. So that's how RAG or retrieval augmented generation works. Maybe I can go into now I can explain some of the behind the scenes about RAG. But before that, like here's an example query, like what is lightning density? Um, Chances are an LLM might not know what that is. So what we do is we took the proprietary data, put it in a knowledge base, and based on that context from the knowledge base, we were able to answer that. And we were also able to provide the source for that, which is a lightning statistics that we had. So if we click on that link, we are going to get straight to a PDF document that shows where the exact page of that document, where this information came from. So this is how RAG works. Bing Chat is a pretty good example of that. Let's just move forward. I will explain some behind the scenes for RAG, and then I'm going to take some more questions. So imagine you have a query, anything like what is lightning density, what is, for example, Vaisala, what is the population of Finland, like just some random question. What happens is that you take that query in a text format and you convert that into a vector. So vector is a long, like a long list of, or a combination of floating points, right? So this is like a vector can have multiple dimensions, like it can have like a combination of 300, 400, 1000 different numerical, or it's basically a numerical representation of text data. And then what happens is that this vector is sent, or query is sent to a vector database. So vector database are a new thing. They have become popular ever since generative AI came into play. And let me just explain a bit about vector databases. So down here you see in this gray area about, I will explain how vector databases work. So basically, for example, we prepare how do we prepare our knowledge base? So that would be the question. So for example, you have a collection of PDF documents, or for example, just one document right here. It can be anything. You take that PDF document, you parse through that document, you extract all of the textual information in that document. And once you have that blob of textual data, you chunk it. You chunk it into smaller sizes, like maybe small paragraphs of 200 words, 100 words. These small chunks are then converted into vectors again. So everything, your query, your chunks, all of the information is then converted into vector, or these are also called embeddings, vector embeddings, by a process called embedding. By that process, all of it is stored in the vector database right here. And in a way, how vector database works is that whenever you give a query, that query is converted into a vector. That vector goes into the vector database, and then what vector database does is it tries to match the query with the most relevant or the closest information chunk that's in the vector database. So in a way, your query is matched with the most relevant chunks, and then those most relevant chunks are retrieved from the vector database. So once you have those most relevant chunks, those chunks are then passed to the context window. So for those who are not aware, LLMs don't have infinite memory. So LLMs can ingest what, like 4,000 words in one go. So they don't even have that memory for the chat. So when we are chatting with ChatGPT, it feels like it remembers what we are saying. But what happens is that it can only remember up to 4,000 words of that chat, beyond which it can't. Like there are new LLMs coming out that can ingest what, like 8,000, 16,000, 25,000 words or tokens in one go. But for the sake of the argument, a basic LLM can only understand 4,000 words, and beyond which it can't understand anything or relate to anything. So what we try to do is we retrieve the most relevant chunks based on our query, and we try to fit that in the context window of the LLM. And then we also leave some room for, I would say, the next answer, or some room for the answer plus some room for the next question. So we want to ask the next question, but we also want to retain some memory so that the LLM remembers what was asked in the previous question. And based on that context window, all of that is fed to the LLM, and the LLM analyzes that context and gives us an answer plus the sources. So the source comes as a metadata in the context. So the source is already there, it's immutable. So that's how the RAG works behind the scenes. And I think it's a very simplistic or comprehensive, I would say, explanation of how RAG works. I can take some questions and answer now because I think this is something people might be pretty interested in. So let's just see what the first question is. So Shamuel, question for Q&A discussion: how integration between LLM and RAG can support development quality AI and digital technologies for education. All right, so first thing for development quality, I think what RAG can help us is that each company, when they're developing something, they have like maybe extensive documentation for it. And when we have like a large number of teams working on different products within the same company, they might not know that some other team is working or tackling some similar problems. So if you have like a RAG on the company knowledge base or development documentation, maybe, then you can ask questions based on that. And for example, digital technologies for education, I think that use case is pretty much what Khan Academy has been doing right now. They're using AI to teach children, or I think everyone now. Even I studied from Khan Academy at some time. So I hope this answered your question to some point. And then next we have Hari. He's asking, is fine tuning same as RAG? And this is a question I've been asked a lot, but basically no. What fine tuning teaches a certain structure of input and output, or it teaches the LLM to behave a certain way. Fine tuning does not necessarily give new information to the LLM, but RAG is something that gives new information to the LLM. So for example, if you want to teach your LLM to output Python code, you need to fine tune it for Python code. But for example, if you want to teach your LLM to explain the documentation of that Python code, and for some new library which was not in the training data or the original pre-training data of the LLM, then you need RAG to connect to that new information source and pull information from there. So Yeah, so that's for your answer, Harry. Next is Kumar, how to onboard LLM in large organizations if the LLM is from third party, LLM uses vector database. Um, if you're using a third party LLM like an OpenAI or Bedrock from AWS, then it's very easy. They provide an API. You can use that API, and then you can use, if you're building the rest of the application is in-house, then there's a library called LangChain. So that LangChain library provides all the functionality to you to connect to the vector database, connect to the LLM, and I'm going to show you in the demo as well. So that's it for you. Then next we have RJ. Uh, okay, I have so many questions. I wasn't expecting those. All right, how do you prevent the LLM from using other content when answering, even though knowledge-based content is engine? Okay, how do you prevent the LLM from using other content when answering, even though knowledge-based content engine? So basically, LLMs have already been trained on summarization task. And what summarization task is, you give an instruction to the LLM and you provide some sort of a chunk of text data, and then you ask the LLM to summarize. So basically, the principle of RAG is pretty similar, where you give the instruction to the LLM to only answer from the context provided and not to, if there's nothing in the context, just say no. So that's how the LLM binds itself to answer just from the context that we are providing. So yeah, that's it for you. Jeff, will this presentation be available after the session? Yeah, for sure, you can have it. I think no worries. I will share the link to my GitHub page, which has the Jupyter Notebook as well as this presentation. You can have it from Data Science Dojo. Is it better to have, then we have Orlando? Is it better to use smaller chunks or bigger chunks? I think that depends on your experimentation. You have to see for your own use case which is better for you. And then we have Naveen. So an LLM is stored as a vector database, and a query is also quantized stored in a vector database. No, LLM is not stored as a vector database. Vector database is something separate. LLM is separate, and vector database are two different components. Your chunks or your PDF documents or your information is stored in the vector database. Yeah, and a query is, yeah, sorry.
I was going to say, Omar, let's after this question, let's continue with the presentation, because
Yeah,
I
I
can
was
see
thinking.
there's more and more questions
Yeah,
coming.
there are just too many. I think I can then take the rest of the questions after I'm done with the demo. Yeah, so yeah, once the RAG, so there's some pros and cons for doing this retrieval augmented generation. For example, the pros are pretty obvious. You get up-to-date information, you can get the sources with information, and you can trust that the information is factual. But then again, there are some cons as well, like the retrieval system or the vector database that you're using, it might not be as good. There are issues with performance. It might not retrieve the right chunks that you're looking for, or sometimes it might not retrieve anything. So you have to do a bit of prompt engineering. Uh, then again, it's a combination of retrieval or vector retrieval system and the LLM. So you have to play around a bit with the architecture and the combination to figure out the best match for it. So yeah, let me just go for the demo. Let's do a simple demo of retrieval augmented generation and how you can get started, and then we can move on to the questions. Yeah. All right. Here is. Again, let me just share another screen. Yeah, can you see this one? This new Jupyter notebook. Can someone say yes, no?
Yep, we can see it.
Yeah, all right, great. So retrieval augmented generation. So the first thing is you have to install the dependencies. The most common ones are LangChain, OpenAI, data sets if you want some like pre-prepared data sets from Wikipedia or something like that, and the transformers library if you want to run your own LLM or encoding model. So the first thing is that you need to load the document and split it into different chunks. I'm using a library called LangChain. LangChain is pretty good. If you wanna like LangChain, if you're building LLM applications, LangChain is the first library you should look up to. And it provides all the functionality you would need to build in a pretty good production-ready LLM application. Yeah. So next we are gonna initialize a text splitter. Basically what text splitter does is it defines the size of the chunks. So the chunk size is 300 characters. Each chunk would have 300 characters, and we do a bit of overlap. Why we do an overlap? So that the chunk should have some of the information from the next chunk and the after chunk. So before and after. So as not to lose some information. You can play around with that, no worries. I already have this generative AI report that I have opened on my right side. I'm gonna load this I'm gonna load this, split this, and add this to my vector database. So you can see it took me just 1.2 seconds to load and chunk it. I'm gonna visualize some of the chunks right here. So this is how the chunks look. So you have the page content, which is like this, which is the text data. And then you have some of the metadata. So you have the source where this information came from. And then you also have the page number where this information is coming from. So, and there are many chunks. I'm going to show you later how many chunks there are in the vector database. So once I've prepared my chunks from my PDF file, I'm going to start a vector database and start adding those chunks to that vector database. Again, I'm using Chroma. Chroma is an open source vector database that you can run on your local machine or hosted on maybe an EC2 instance in AWS. And for embedding, so for we also need an embedding model. OpenAI also provides an embedding model, but I'm using an open source one, which I can run on my local machine. It's called All Mini LM L6v2. There are many available. You can just check them out on Hugging Face. So I'm just initializing my embedding function, and I'm going to show you what embedding does. So yeah, so my embedding function is loaded. I'm going to show you what embedding does is, so I ask it to embed a sentence. This is a test, right? And now I'm showing you the embedding. That string is converted into this large numerical vector. And then the dimensions of that vector are 384. You can have different embedding models. Some embedding models would give you like 400, 500. The OpenAI's embedding model gives you like 1400 dimensions. By rule of thumb, more dimensions are the better the detection accuracy of the vector database, but this is still open for interpretation. Further research is needed. So now I've initialized my vector, my embedding function. I need to provide that embedding function and those chunks to the Chroma DB. So what happens is that this Chroma object, it takes those chunks and it uses the embedding function to convert those chunks into embeddings and store that in a database. So I'm uploading all those chunks to the vector database now. It's going to take some time, not too much, maybe 10 seconds, 12 seconds. Let's see. Yeah, 13 seconds now. And you can see that I've uploaded all the chunks in the vector database. So chunks in DB are 395 from this 48-page PDF. I've chunked it into 395 small size chunks. And now I'm gonna set up my retrieval from the database. So I can ask the database some query and I can retrieve some most relevant chunks based on that. So for example, what is generative AI? I asked that question from my vector database, and these are some of the chunks that got retrieved from that vector database, right? And this is what happens. You get these chunks or the most relevant chunks, and then you're gonna push all of those chunks into the LLM context. And then the LLM gonna go through these and provide you some answer or factual answer based on this information. So now I'm going to set up the RAG architecture. It's very easy. The pipeline is pretty easy to set up with LangChain again. So first I'm going to do is I'm going to import my OpenAI key. I'm using OpenAI, but you can again use some open source LLM or other LLMs provided by Claude or I don't know. So set up LLM connection. I'm setting up my LLM. I'm using GPT 3.5 Turbo. And now I'm going to connect my vector DB to the LLM. So again, referring to that question, like, is the LLM stored in the vector database? No, LLM is a separate component and a vector database is a separate component. So I'm initializing my vector database and LLM connection. And I'm going to ask a RAG question, like, what is the impact of generative AI? Let's see if it returns something. Yeah, so here you see, what is the impact of generative AI? So yeah, the impact of generative AI includes concerns about bias in the results produced by these models. Then there's some source, and then there's some answer and the source as well, where this information is coming from. And then you can ask some other questions, like, for example, what is Bloom? So Bloom is another LLM. You can ask a question like this. Let's see what it says. Yeah, which is an open size, yeah. So this information is relatively new. This PDF got released this year. It would not be available in the memory of ChatGPT when it was trained, which is GPT 3.5, which was trained up to 2021. So I'm going to ask some more questions. For example, generative AI, maybe something about, let's see. So let's ask something more. So, for example, what is BERT? BERT is another model. Yeah, there might be. Yeah, so it's pulling that information from the most relevant chunk that is most likely coming from here. So this is, and then you guys can, I'm just finishing up. So that I think this is how you can play around with RAG. You can have access to this notebook. Please be noted that you guys need your own OpenAI API key. So to play around with that or get access to some other model from AWS, it's up to you. But this is how RAG works. This is how you set it up and the theory behind RAG. And yeah, that's about RAG. And if you have any other questions, please let me know.
Omar, one of the questions that just popped in is that I think will be interesting. Can you ask it something that is not in the document, like maybe about brain surgery?
Let's see. I would be surprised as well. How do I perform brain? Yeah. Let's see. See, it says, I don't know how to perform brain surgery because there's no source for that in the document that I'm using on the right here. Does that answer your question?
Oh yeah, yeah. The person just wanted to see what the outcome would be.
Yeah. So yeah, shall we take questions now?
Yeah, we've got a lot of them. So.
All right. Yeah, I'm really surprised. There are like 14 questions. All right. So Hari, can LLM only give source if context is passed? Not otherwise. Where is this specified? So when we are initializing the LLM, there's a message in the settings. So we have already set it up behind the scenes. You can go into the details once you start using LangChain, but you actually set up a system message where you tell the LLM to only the source is going to be mentioned, which answers the question. So if there's no source, the questions won't be answered and the source won't be given. So that's how it works. Yeah, then psi is the chunk as a whole represented as vector entry, or the vector is something else, something that is generated per word. No, the word, the embedding or the vector embedding is generated for the entire chunk and not for the word itself. Okay, Avery Lewis, can RAG provide multiple sources that can guarantee where a response comes from, or can it not guarantee that there was no influence from the LLM? For example, in a financial site chatbot recommending investments, in case the company providing the chatbot gets audited by recommended investments. Yes. So if an LLM is providing an information and it is giving a source, chances are, or I would say 99% of the time, that information is correct. But the correctness of the information also depends on the retrieval system. So the vector database has a performance benchmark of its own. So, and that is affected by certain parameters like the chunk size, the overlap, and the quality of the embedding itself. So for example, if you're asking it a very specific question about surgery, right? Brain surgery. And then it asks, and if you are unable to retrieve the most relevant information from the vector database, that is an issue of the vector database and not the LLM itself. So it's a complicated thing to balance the vector database output and the comprehensive power of the LLM, because the sources are going to come from the vector database and not from the LLM. So I hope that answers it. Bill, Michelle, is there a minimum size of vector encoding for a vector database to actually add? Which encoders have you used in your work thus far? Spaces, 300 flows, stinks, and what I've tested. So yeah, I've been basically what I did is I used OpenAI's embeddings, and then I used this embedding, open source embedding from Hugging Face. There was no difference, at least I couldn't discern it. And there's also a pretty good, I would say, benchmark on Hugging Face regarding the efficiency or the performance of the embedding model. So you can go to Hugging Face, check the performance of the different embedding models, and you would have a fair bit of idea. And they are roughly the same performance. There's not too much difference between different embedding models. So you can use something with 300 dimensions or something with like 2000 dimensions, and the performance won't change that much. At least that's what I've found so far. Okay, Sumit, what are the different vector databases which are leaders in this space? So this is a tough question to answer because I tried out FAIS, which is the Facebook's vector database. There's also a vector database provided by AWS. I use Chroma because it's one of the most popular open source vector databases. Pretty easy to use, great support, huge community following on this one. So just use something that makes sense to you. There's no binding because I think the underlying tech is the same or more or less, whichever gets your job done.
Yeah,
So that's
and
what I would say.
and Omar, if I can add in Sumit, in our
Mm,
large language model bootcamp, we use Redis.
yeah,
So that's another one, and I know
Mm,
there's more out there.
Yeah,
But
if you go to LangChain, I think there are like 12 right now that you can see, at least 12. Can you ask a question with and without the RAG live here? Okay, I would actually have to set up my code to ask a direct question, but a direct question would be something if you ask like just chat GPT, right? So the chunk sometimes does not start with or end with full sentences. How does ChatGPT makes it a good human friend answer on top of the most relevant chunks? So yeah, the chunks are split randomly, or I would say split with a definite length size, and it does not matter whether the chunk starts at the start of the sentence or at the end of the sentence. But this is something you have to play around with. I think it does impact the performance of the retrieval system to some extent. How do you parse your information and then split it is a project or a research topic on its own. And this is something you should play around to have a good answer. This is something I can just say from my experience alone. Okay, okay, there are so many. Faye, how does Bing work? How does it mean that it's a very large vector? Do we thank you? Yeah, I think it does. It's using RAG architecture as well to provide you sources. It's using OpenAI's GPT-4 and a combination of RAG architecture to give answers based on internet data. If I want to run LLM, Hari, if I want to run LLM, is there a way to make it smaller or subsetty? Yeah, so if you want to run an LLM, for example, let me just stop sharing. That would be, yeah, so here I am back. Okay. So yeah, if you want to run an LLM, you basically reduce the bit size of each of its neurons. So there are different versions. Use a smaller open source LLM like Meta's Llama 2, or with a size of 7 billion or a 3 billion model. It's gonna fit in your local machine. You can run that. There are different, I would say, tutorials on how to do that. Just Google it and check on YouTube. There are pretty great tutorials on how to run an LLM on your local machine. Okay. Ali Heather Shalwani, which one is efficient among PEFT and RAG? So PEFT is a fine-tuning technique and RAG is a data retrieval technique. So both are different. So there's no comparison of efficiency between the two. So yeah. Then again, Ali Heather asked another question. Couldn't we use RAG for, okay, so I think you're asking someone else, and I'm not sure. Francis, okay. Couldn't we use RAG for LM for faster retrieval data? Yes, that's why we are using RAG instead of like training from scratch. Naveen, follow-up question. When you query the LM through the RAG, who pays for the cloud access that the LM relies on? Actually, I am paying for the OpenAI API for each invocation, for each word or token. I'm paying for it. So when you're using it, make sure that you have an account and you're paying for it. If the images within the PDF contain text, can that be read by the model as well? Only if you have been able to extract the text from the image. And there's a whole methodology on how you can do that. Basically, you use OCR. It's an algorithm that can read, it's a machine learning algorithm that can read text from images. So you can use that, extract the text, and then feed it to the LLM to get an answer. So Sai again, in the demo, you're using pre-trained OpenAI LLM model, not train a barebone model and use that to predict, right? Yes, correct. We are using a pre-trained model, and then we are using external information with RAG. Jim, are RAG-enabled responses still likely to suffer from hallucination? Highly unlikely, but there might be some case where the retrieval system is not working well, so you're getting irrelevant information, factual, but irrelevant to your question. So you can say it in a way that it's hallucination, if not entirely. So Hari again, if I pass the samples in the prompt itself compared to using that, this also consider a context being passed to the LLM. Yeah, so basically you're providing additional context to the LLM yourself, and some other context is going to be provided by the retrieval system. So whatever information you're providing to the LLM is context itself. Okay, so RJ, what is the deciding, what is, I don't know how to perform brain surgery's code, making the decision and telling the LLM to make that reply. So basically how to perform brain surgery, what happened is that that query went into the vector database. It could not find anything regarding that the most relevant chunk based on that, so nothing got retrieved. So when you're retrieving something empty, the LLM understands that since there's no source, it can't answer anything. It just has to say, because it has been programmed or instructed to say no. So that's how it answers. Okay, Kumar Bidala, the main purpose of RAG is to compensate data deficiency of some of the private data. Yes, yeah, your understanding is right. You're basically augmenting your LLM with private company data. It helps a lot. What happens, then we have Mahanas. So what happens if information from LLM and RAG are contracting or maybe contradicting? LLM does not use its own information, rather it uses the comprehensive power or the power to understand the context. And then based on that context, it only answers, not from its own information. And then Bira, we have, when you ask it about brain surgery, it could have reason to sort out the answer from the LM. What's missing from your demo? I didn't refer to the LM for the answer. So basically, the LLM has been instructed to not answer when there's no source for it. So rather than answering based on its own, it just if there's no context or no source, it's not going to answer. So that's why instead of reasoning itself, it just said no. Leroy, is there a way to control retrieval such as by keywords or semantically? Yeah, there are different methods. There are different search methodologies as well. It's up to you how you want to do that. There are plenty of resources in LangChain to do that. And Sai, what is the use of embedding? It's like it is used like a seed to encode the chunk for vector generation. So basically, so embedding is used. It's a numerical representation in a very high dimensional space of your text. So basically, it's very hard to compare text to text, but it's easier to compare one numerical vector to another numerical vector. So that's why we are using vectors instead of comparing directly the text from the query with the text from the chunk. Okay, Christine, what's the equivalent of PyPDF loader loading public websites? I think there is another one. There's another library called unstructured that you can use to load up different types of content. But if you go to the documentation for LangChain, they also provide loaders for HTML content as well. What is the link for the notebook? Yeah, I think I'm gonna share the link for the notebook as well, GitHub link, so you can just do that.
And I should mention that we'll have the GitHub link with the recording, so you can find that on Data Science Dojo's YouTube channel, datasciencedojo.com/tutorials. Or if you go back, if you're in Zoom, I know you RSVP'd on our webpage. So if you go back to the events page where you see all the events, click the past tab and you'll see Umar's event there. And we'll have the GitHub link added as a resource. So there will be plenty of opportunities to get that.
Yep. I think we are done now. If there are any more questions. Yeah, I think the last is from Hari. How about parsing tables in PDF? And I think, yeah, you can use some ready-made tools for parsing tables. For example, PDF Plumber is a very good library to extract tables and convert into text string that's readable by the LLM. But LLMs generally are not really good with structured like tabular data. So you have to play around with that on which LLM is going to give you the optimal answer for that. So yeah, that's it.